Hello and welcome to our next section in geometry, 1.5 angles and their measure. This is going to be on my page 6 if you want to pause the video really quick, get this down, as well as the title on the actual my page 6. So I actually need to write that in really quick. And let's get started. Ray is a new term. We've had line segments, line segments, and then now we have rays. Ray is kind of an in-between between what a line is and what a segment is. A line we know goes on infinitely in both directions. In other words, it has arrows on both ends. A segment has endpoints on both ends. The middle point between this would be to have one endpoint and one arrow. So that is what a ray is in essence. So a ray is part of a line with one endpoint. I'm going to underline one endpoint that extends infinitely in one direction. So let's start off with just a endpoint and endpoint. I'm going to draw a line going to the right, and I'm going to draw an arrow on the other end. So here's the one endpoint, and then here's the infinitely in one direction part. It's going to the right. It doesn't always have to go to the right, but it can. It could also go to the left. It doesn't quite matter as long as you have one endpoint, and then that's pretty much it. One endpoint, and then the other side, the other part of it is one arrow. Okay, I'm going to mark this AC. Okay. And I'm actually going to put a point between A and C. I'm going to put B here. Not quite a midpoint. We're not going to get into that one. But here we could call this, for instance, ray AC. Now it's very, very important what we start with. We always start with the endpoint. So in this particular case, we start with A because it is the endpoint. I'm going to shorthand endpoint, okay? And we also should note that if we shorthand it even more and we take out the ray part, we could also technically call this AC, but we're only going to have one arrow. And it's going to start at the endpoint, like you see, like we do know that it's at A. A is the endpoint, and then have the arrow on the C side. You don't have to put a dot here because it's implied that this is an endpoint. And you could even go as far as, since we have B there, we could also technically call this ray, there's another ray on here, BC, okay? Or even call it AB because it goes in that direction. You could actually call this AB if you wanted to. Because if the fact that if we, for instance, if we omitted C altogether, this would be AB. The direction we are going is towards B, and it goes on infinitely in that direction. So AB would qualify as a name for this. Okay, you cannot go backwards. I'm going to put the C back here. You cannot call this CA. That would not work. So or you cannot call this a CB. That would also not work. So I'm just putting this here just to cross these out because you cannot call a ray towards its endpoint. You cannot name it that way. Okay? So a ray is now done, and now we have all the versions of lines that we could possibly have. Lines, segments, and rays. Those are the three different types of lines that kind of occur. Okay? And with rays come angles. So we are going into some two-dimensional geometry. Angles. An angle is formed by two rays that have a common endpoint, or that share a common endpoint. Okay, so for instance, if we if we draw an endpoint and draw a ray that goes to the right, I'm going to call this I. I'm going to call another point towards the arrow G, and then I draw another ray starting at I as an endpoint. And then put another point towards the arrow. I'm going to call this P. This actually, we have two rays, PI, and IP is the ray, and IG is the other ray, and they share the common endpoint I. Okay? We call this point the vertex because it is kind of the common, it is the endpoint, it is the common endpoint. Common or shared endpoint. In other words, it's where pretty much the two rays meet, okay? These two rays share that endpoint and they form an angle. This angle here can be named a bunch of things, okay? So we have sides to them. So I'm gonna label this here. Let's actually use blue, just so we can organize this a little bit. We have sides of the angle. And these sides are named after the rays. Actually, let's kind of go in between this so we could kind of avoid this. The sides are IP. When we draw the ray symbol, we use the one arrow, and IG. Okay, so those are the sides of the angle. And then we have the vertex, which is the common endpoint. And then we actually have the names of them. So I'm going to put the names. We can name this angle a number of different ways, okay? Angles are typically named with 3 letters. And it's very, very important what that middle letter is because the middle letter has to be the vertex. So for instance, if I call this angle, and this is a symbol for angle, it looks like a capital L, but it's kind of slanted. Angle, PIG, is a proper name for an angle. So we should notice the vertex is the middle letter. Okay? We could also technically call this angle GIP because it's the reverse order. In other words, if you trace this angle, it should create this red line, this gap, okay? So if I did PIG and I traced it in this direction, it creates that angle. Same thing if I go from G to I to P, it still creates this particular angle. So as long as I is the vertex in the name, I is the vertex and the vertex appears as the middle letter in the name, then you are pretty good, you're pretty much good to go, okay? Now, you could also have, for instance, numbers. For instance, if I put a number 4 here and there's no degree symbol here, okay? If it's just a number 4 and there's no degree, then you could also technically call this angle 4. So you could also say, or this is angle 4. And last but not least, this is the trickiest of them all. If you could also technically call it by one letter. So if you notice here, it has the vertex of I, angle I. That is where the angle is actually positioned, and you could actually call this angle I. This is an exception though, and I'm going to put a little star by this. And you could only call it angle I because there is only one angle. One angle, sorry, let's not use a shorthand, angle at I. I'm going to show you a counterexample to this. If I, for instance, have another angle, this is in pink, you don't have to copy this down, and let's call this angle WO, and then I'm going to put an L here and an F here. Okay? There are actually a number of angles in this diagram. If you were to say that there are 2 angles, you're actually wrong. There's an angle here, WOL. There's an angle here, Notice I'm using tick markers, 2 tick markers for angles. If there's LOF, and then there's actually the whole angle combination of the two, WOF. Okay, so there are actually 3 angles here. And if I said, for instance, just angle O, how would you know which of these 3 angles I'm actually talking about? Am I talking about WOL? Am I talking about LOF? Or am I talking about WOF? So you could name an angle I only if it fits the criteria that it is the only angle at that particular point. In this particular case it is, but in the pink it is not. So I'm going to erase this, and make sure you keep that in mind. There are a lot of different types of angles as well. Okay, so here we're going to do a little bit of a breakdown. Types of angles, and this hopefully is just a refresher. We have 4 different types of angles, and you might know 3 of them, and you might not know the 4th one because it's kind of uncommon to talk about them. The first type of angle looks like this. Ooh, that's supposed to be curved. And it is an acute angle, which means we have an angle whose measure, is, and I'm going to put the angle X, I'm going to put X degrees, or X there. It's going to be, I'm going to put X in the middle. An angle whose less than 90 degrees, but greater than 0. You can't have an angle of 0 degrees, so it has to be greater than 0, but less than 90 degrees. Okay? With acute comes obtuse. So we have an obtuse angle. And then this is an angle whose measure is, I'm going to put X in the middle again, so I'm going to call this X. Put that little tick marker. Whose angle is greater than 180 degrees. I'm sorry, greater than 90 degrees, but less than 180 degrees. Okay? We also have a right angle. Very, very important that we use a square to indicate a right angle. Square indicates a right angle. Always. If it looks like a right angle but doesn't have the square, then it is not a right angle. It can be 89.9 degrees, okay? So here, this is our angle X. So X is exactly equal to 90 degrees. And the last one, and I should have left a little bit more room. I said we would use 4. I'm going to have to shift this around just a little bit. Last angle is what we call a straight angle. Call this X. An angle whose measure is exactly 180 degrees. So this is a straight angle. So those are your 4 types of angles based off of degrees. Okay? So I should probably put that here, based off on degree measure. All right. We also have congruent angles. So if we already know the definition of congruent. So congruent angles, I'm going to actually do this on the next page because it's going to carry over no matter what. We have 2 more things to talk about. Congruent angles should be obvious. Are angles, 1 or more angles, or 2 or more angles, I'm sorry, are 2 or more angles with the same angle measure. Okay, so I'm going to draw 2 different triangles. Here's one. Let's call this ABC. Okay. And then let's draw another triangle. Let's call this XYZ. All right. So if, for instance, I put a tick marker here, and angle ticks are just kind of curves, and hopefully you recognize that when I did the diagrams. Angle tick markers are curves, okay? If A, for instance, is, let's say, 60 degrees, and then B is a different angle measure, I'm gonna call this 70 degrees, they would have two different tick markers because they're different. You need to distinguish them by as so. So I'm actually going to erase those angle measures because it's not, this in itself should be enough to tell you that A is not congruent to B. But if you look at another triangle, for instance, Y, and I'm going to put one tick marker on X, that should indicate that A and X have the same angle measure. So in this diagram, we could then say angle A, and we are allowed to do this because there's only one angle at this particular vertex, is going to be congruent to angle X. And we could do that as well. Technically, we could call this, I'm going to do this in pink, you don't have to copy this down. If you want to be fancy about it, angle BAC is going to be congruent to angle YXZ, because the those particular angles or vertices are congruent. They're the middle letters. So congruent angles have the same tick mark number, or number of tick marks. Okay. The last term that we need to talk about is what we call an angle bisector. Now, a bisector is exactly, hopefully, what it sounds like if you break down this word. Bi means two. Sector means sections. So an angle bisector is a ray, segment, or line that divides an angle into two congruent angles. So if you really think about it, this is kind of what a midpoint does. If we remember what a midpoint is, a midpoint divides a segment into two congruent segments, right? An angle bisector will do the same. Except this time around, I'm going to just keep this to the right as a visual. If we have, for instance, let's use black, an angle here, and let's say, for instance, we have F, I, and then call this H, and then straight down the middle of this, we have S, a point S. We could indicate on this diagram an angle tick marker of 1, another angle tick marker of 1, that these two angles in particular, now we have to name them because if you notice, I is, if I called angle I, we have multiple angles there, so we can't say angle I, we have to name the long way. Angle FIS and angle SIH have one tick marker, right? So we could actually say that these two angles are congruent. So if I, for instance, said that this was 30 degrees, we would then say that this is also 30 degrees, okay? But we don't need that. We would then just use tick markers. We could even do tick markers like this as well to show like a physical tick, like how we do on the line segments. But having the angle ticks or the curved ticks is good enough, okay? So here we have it. And we could also say here, since FIS, angle FIS is congruent to SIH, we could say that IS, ray IS, is the angle bisector to angle FIH. And there we have it. If you have any questions, please ask, let me know, and I will see you in the next one. Bye.